Now, the students, next the concept. So, name and draw the shapes which possess linear symmetry but no point of symmetry and rotational symmetry. There is no point of symmetry and there is no rotational symmetry, only they have line of symmetries. Such figures we should draw and see. So, which figure is having only line of symmetry, and so which figure do not have rotational symmetry and point of symmetry. See here, the first one, angle. So, this is AOB is an angle. So, then this angle, so if you draw an angular bisector of this angle, so angular bisector, so draw an angular bisector. So, this is an angular bisector which divides the angle into two equal halves. So, that means AOC angle is equal to COB angle. So, these two angles are equal. So, OC is the angular bisector of AOB. So, this angular bisector OC is a point of symmetry, line of symmetry, is a line of symmetry of this angle. AOB angle line of symmetry is OC. So, which is a line of symmetry? So, which is a line of symmetry in angle? So, the line which bisect the angle into two equal halves, that is the line of symmetry of a given angle, Here the given angle is AOB. This AOB angular bisector is OC. So, this OC is a line of symmetry of this angle AOB. Okay, and here, so there is no point of symmetry. So, like in a rectangle we have a point of symmetry, in a square we have point of symmetry. So, in rhombus also we have point of symmetry, in circle also we have point of symmetry. So, point of symmetry, here we do not have any point of symmetry. So, and here also we do not have any rotational symmetry also. If you rotate it 90 degrees, so we do not get the same shape, and at 180 degrees also we do not get the same shape, and 270 degrees also we do not have the same shape, and 360 degrees. So, in all these angles we do not get a same shape. So, that is why we do not get rotational symmetries. So, here the angle, whatever the angle it is, either 60 degrees, 45 degrees, 30 degrees, whatever angle. So, in all the angle we have a line of symmetry. So, that is angular bisector. Angular bisector is the line of symmetry of a particular given angle. So, then for any angle, so there is no point of symmetry and there is no rotational symmetry. Okay, this is about angle. Now, the next one, the second, an isosceles triangle. So, in this isosceles triangle, so we have a line of symmetry. So, how to take line of symmetry? So, if you take a vertical line, so from x to opposite side, so midpoint. So, this is this vertical line. So, we should draw a perpendicular line, or otherwise, so we should take a perpendicular bisector of yz and which passes through the vertex x. So, that divides into two equal halves, that is left side and right side. So, it divides into two identical shapes. Vertical line of an isosceles triangle divides into two identical shapes. So, this vertical line is a line of symmetry. Here we do not have any point of symmetry and we do not have any rotational symmetry. If you turn it at 90 degrees, you will get another shape, at 180 degrees another shape, and 270 degrees you will get another shape. You are not getting the same shape of a isosceles triangle. So, that is why this isosceles triangle is not having a particular shape of a, means the same shape at 90 degrees, at 180 degrees, at 270 degrees and 360 degrees. So, this isosceles triangle is having only line of symmetry. So, there is no point of symmetry. So, here there is no point of symmetry, there is no intersection point. So, that is why we will not get the point of symmetry, and also we will not get rotational symmetry also. Okay. So, now the next, semicircle. So, this is a semicircle, half of a circle. So, then half of the circle, so it is having a line of symmetry. So, what is the line of symmetry? So, suppose xy midpoint, suppose here we have a xy midpoint. So, that is the center of this xy. if you draw a vertical line from this point, if you draw a vertical line from this point, so then this vertical line divides this semicircle into two identical shapes, two equal halves, that is from left side one equal and right side. So left and right it divides into two identical shapes. So this line L is a line of symmetry. So line L is a line of symmetry of this semicircle. So here also the same. So this semicircle is not having a point of symmetry and is not having a rotational symmetry. It's having only one line of symmetry. So all these three pictures having only one line of symmetry. So in angle, angular bisector is a line of symmetry. In isosceles triangle, the vertical line is a line of symmetry. And here semicircle, the perpendicular bisector of xy, that is the diameter of the semicircle. So that is midpoint of the diameter. So vertical line, so the line which draw from the center of this xy, that means midpoint of xy. So that vertical line is a line of symmetry of this semicircle. And this all the three figures, they don't have a point of symmetry and rotational symmetry. The next one, here kite. So here in this kite, so kite is also having a line of symmetry, only one line of symmetry. So if you draw a vertical line, so this is a vertical line. So this vertical line divides into two identical shapes. One is left, other one is right. So left and right both have identical shapes. So but if you draw a horizontal line, so the upside and downside, so they don't have identical shapes, they are different shapes. If you draw a vertical line, then left side and right side, so they are identical shapes. So this vertical line is a line of symmetry, and here we don't get a point of symmetry and we don't get a rotational symmetry. So in this case also. Now, so isosceles trapezium. So in this isosceles trapezium, so then here also if you take a vertical line from the midpoint of AB and CD, then you will get two identical shapes, that is left and right. Left side and right side you will get two identical shapes. If you take horizontal line, then you won't get the identical shapes up and down. So the two different shapes you will get, so that is why. So if you take a vertical line, then only you will get identical shapes. So that is why this vertical line is a line of symmetry, and here also we don't have a line of symmetry and means point of symmetry. We don't have point of symmetry and rotational symmetries. Only one line of symmetry is there, that is vertical line. Okay. So in all these five geometrical shapes, we have one line of symmetry and there is no rotational symmetry and there is no point of symmetry. Okay. Yes. Now the students see here. So the next one is equilateral triangle. So in this equilateral triangle, so how many line of symmetries we have? Then what about the point of symmetry? So what is the rotational symmetry? See here, line of symmetry. If you draw a vertical line, so this vertical line divides into two equal halves, the two identical shapes left and right. So this is a line of symmetry. So when we draw a vertical line from a point P to the opposite side QR, so then that vertical line divides into two equal halves in a equilateral triangle. So that is left side and right side. So we will get two identical shapes. So this is a line of symmetry, and one more line of symmetry we will get from a point Q to opposite side PR. So then you will get a line of symmetry. So here, so this side and this side you will get two identical shapes, up and down you will get two identical shapes. So this is one line of symmetry. And another line of symmetry, so if you draw a line from a point R, so then this one is also divided into two identical shapes, that is one is upside, another one is downside. So in equilateral triangle we have three identical shapes from all the three vertices, P vertex, Q vertex and R vertex. So if you draw a lines, so P, so this from the point P to opposite side QR, so that divides into two equal halves, the two identical shapes. So if you take S, T, U, that means PS is one, so line of symmetry, QT is another line of symmetry, RU is another line of symmetry. Now, point of symmetry. So, here in equilateral triangle we do not have a point of symmetry. Why? Because it do not have a point of symmetry. Because, so here there is no point of symmetry. So, no point on a symmetry on a symmetrical line. On a symmetrical line you will not get point of symmetry. So, that is why this equilateral triangle is not having a point of symmetry. Remember this one. So, then what about this rotational symmetry? So, if you rotate at 60 degrees, then 120 degrees and again it is 120. So, if you turn this triangle at 120 degrees, after that 240 degrees, after that 360 degrees, then you will get an equilateral triangle. So, first it is at 120 degrees. So, you will get the same equilateral triangle. Again at 240 degrees you will get the same, again at 360 degrees you will get the same. So, you will get 3 rotational symmetries. So, in equilateral triangle we have 3 line of symmetries, 3 rotational symmetries, but we do not have point of symmetry in equilateral triangle. Okay. In scalene triangle, all the 3 sides are different, xy, yz and xz. All the 3 sides are different in length and all the 3 angles are different in length. So, this scalene triangle, so you do not have a line of symmetry, point of symmetry and rotational symmetry. Why? If you take any line like this, so we do not get identical shapes, up one and down one. So, they are not identical shapes. If you take one more line from the point x, from the vertex x, so we do not get identical shapes. So, we do not get the same shapes. So, that is why this scalene triangle is not having a point of symmetry, line of symmetry and rotational symmetry. Why? Because this scalene triangle having a different lengths, all the 3 lengths means 3 sides lengths are different, x, y, y, z and z x. So, that is why this scalene triangle is not having a point of symmetry, line of symmetry, rotational symmetry. Okay. Now, so in this parallelogram, so first, so line of symmetry. So, if you draw a vertical line, you will not get identical shapes. If you draw horizontal line also you will not get any identical shape. If you draw diagonal also you will not get identical shapes. You will not get identical shapes. So, whatever, either it is a vertical line, horizontal line, diagonals at anywhere. So, if you draw, so once you check you will get identical shapes or not. No, you will not get identical shapes in parallelogram. So, different shapes means different areas of a shape you will get. So, that means parallelogram is not having a line of symmetry. So, this is the important. So, parallelogram is not having a line of symmetry. Then point of symmetry. Yes, parallelogram is having a point of symmetry. So, where it is having a point of symmetry? The intersection of the diagonals. This is BD is one diagonal and AC is another diagonal. The intersection of the diagonals, is a point of symmetry. The intersection of the diagonal is a point of symmetry. Okay. So, then rotational symmetry. Here the parallelogram is having 2 rotational symmetries. One is at 180 degrees. At 180 degrees you will get the same shape and again at 360 degrees you will get the same shape. So, at 180 degrees, at 360 degrees, if you turn at 180 degrees, then you will get parallelogram only and again at 360 degrees you will get parallelogram shape only. So, that is why 2 rotational symmetries, and so the point of symmetry is at diagonal and this parallelogram is not having a line of symmetry. Okay. In all the geometry figure till now, so only the parallelogram which is not having a line of symmetry. Okay. So, now the students see here activity. So, in the activity, so what is given? Complete all the problems, select the right one, So, in each and every question 4 options are given. So, in that 4 options, so one option we should select and so give a tick mark there. Okay. So, the first question, in the first question what he is asking, see in the picture, so what is given? So, which dotted line is a symmetry, is a line of symmetry. So, which dotted line is a line of symmetry? So, here total 4 stars are given. How many stars? 4 stars are given. The first one, the second, third and fourth. So, in all these 4 stars, So, the which one is a symmetry, line of symmetry, which one is the line of symmetry he is asking. If you see the first one, so that is a slanting line. So, that slanting line does not divide the star into two equal halves, two identical shapes. So, that is not the correct one. So, then B. So, B is a vertical line, so which divides into two identical shapes, that is right and left. So, two identical shapes we will get in the second one. So, the B one is the answer. So, make a tick mark at B. So, in second one, so in that circle is given, there you keep a tick mark. Okay. So, B is the right answer. B is the right answer. Remaining two slanting lines, so does not divides a star into two equal halves. So, the two are not correct. Only the B one is the right answer. Okay. In the second question, see in the second question, arrow is given. So, four arrows are given, upside arrows. Here, so which dotted line is a line of symmetry? Which dotted line is a line of symmetry? Here, so A, B, C and D. So, A is a slanting line. So, slanting line does not divides into two equal halves. A is not correct. B is also the same, and C. So, when you see the second one, so in the C question, so the vertical line divides an arrow. So, given arrow into two equal halves, two identical shapes. The left side and the right side, it divides into two equal halves. So, the C1 is the right answer. C1 is the right answer. The vertical line in C arrow that divides into two identical shapes. So, that is a line of symmetry. That is a line of symmetry. So, C1 is the right answer. The next one. So, students, the third question, see in the third question. So, what is given? So, in your question, so which dotted line is a line of symmetry? Is a line of symmetry. Here, so some group of people is given. So, three members, three men were given. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Three men were given. So, in that the first one, the horizontal line is given. So, no, if you fold that picture, so horizontally, so we won't get two identical shapes. So, up one and down one. So, we won't get identical shapes. So, the first one is not the correct one. The second one exactly in the second person. So, we are taking a vertical line, so from second person. So, second person half and first person, second person half and third person. It means, so that in the second question, the vertical line so divides into two equal halves, two identical shapes. So, the B1 is the right answer. B1 is the right answer. So, in the B1, the vertical line is a line of symmetry. Vertical line is a line of symmetry. Why that is a line of symmetry? Because that vertical line divides into two equal halves or two identical shapes. Okay. The next one, the fourth one. So, which dotted line is not a line of symmetry? Here he is asking not a line of symmetry. See in the three questions what he asked, line of symmetry he asked, but here he is asking, so not a line of symmetry. See here in the first question, the horizontal line, so that exactly divides into two identical shapes, that is a line of symmetry. In the second picture, the vertical line is also divides into two equal halves, two identical shapes, so that is also a line of symmetry. In the third one, so that vertical line, it is not divided into two equal halves. So, the third one is not a line of symmetry, So, the third one is the right answer. Okay. Okay, students. Next, the fifth question. See in the fifth question what he is asking, is the dotted line is a line of symmetry? See here, one smiling face is given. One smiling face is given and one slanting line is given. See the upside and downside, so they are not identical. So, if you take a vertical line, so then that line is a horizontal, that line is a line of symmetry. But here the slanting line is not divided into two equal halves in a smiling face. So, here no is the right answer. No, the line which divides the smiling face is not a line of symmetry, Answer is no. Okay. So, now the students see here. So, in the sixth question, is the dotted line, this is the dotted line. A line of symmetry he is asking. It's a line of symmetry. See here, this is a circle. So these two are the diameters. This is one of the diameter. This is another diameter. So these two diameters, this is a vertical line, so which cuts the circle into two equal halves, that is left side and right side. And left side and right sides, we are getting two identical shapes, two same shapes. So that means, so these dotted lines, no doubt, divides into two equal halves. The answer is yes. Yes. Yes is the answer. Why? Because this vertical line divides this circle into two identical shapes, that is left side and right side. Left and right, we are getting two identical shapes. So the answer is S. Okay, students. See here. So now lab activity. So in this lab activity, so what is given here? So nowadays children like to decorate their hands with tattoos. So here some tattoos are given. So most of the tattoos are symmetrical in shape. Symmetrical in shape. So here two tattoos were given. See, so first tattoo and second tattoo. So in the first one, so pink color and blue color tattoos were given. So they both are pink color and blue color. The both are identical. If you draw a vertical line from the middle, so in between pink and blue, so then you will get identical shapes. Left and right identical shapes we have. So that is the identical tattoo. So in the second one, so butterflies are there. So pink butterflies and orange butterflies. So if you draw a vertical line, so from the middle of a pink butterfly, then you will get two identical shapes, that is left and right. So these are the tattoos, they are identical in shapes. So nowadays we have many tattoos, so which are available outside. So students, they like very much the tattoos, identical tattoos. So once we observe the tattoos, we can observe that they are identical in shapes. Here also the two tattoos, if you draw a vertical lines from the tattoos, then you will get two identical shapes, left and right. So these are the identical tattoos. So identical shapes means the symmetrical shapes are very beautiful. So the tattoos, so we feel they are very beautiful to see. So why? Because they are symmetrical in shape. They are symmetrical in shape, like these two tattoos. Okay, these given two tattoos are also the identical tattoos. Once if we draw a vertical line, so from the middle, so of the tattoos, then we will get identical shapes. Okay.